In your summer work, you also had a few problems that dealt with empirical versus molecular formulas. So this is meant to just give you a quick overview of the difference between those terms. The word empirical actually means experimental. So it's a formula that gives the proportions of the elements in a compound, but not the actual numbers or the arrangement of the atoms. A lot of times these empirical formulas are determined through experiment. They're determined by mass percent. And usually these formulas are going to be the lowest whole number ratio of the atoms that are in the compound. So if you can reduce those tiny little subscripts down to the lowest whole number ratio, that's the empirical formula. The molecular formula is the actual ratio of the atoms in the compound. Sometimes it can be the same as the empirical, and a lot of times it's not. For instance, if I look at this setup here, P4O10 is 2 times as big as P2O5. So the molecular formula is just some whole number ratio bigger than the empirical formula, or in some cases, such as this set right down here, C5H12O, C5H12O, it can be the same. In a typical empirical formula problem, I always go back to the jingle that we used in class last year, right? Percent to mass, mass to mole, divide by small, and then make them whole. So the first thing that I'm going to do with this information that's given to me about vitamin C is I'm going to take these percentages and I'm going to assume that there are 100 grams of this compound. Now, why would I use the number 100 grams? That's because, I could pick 33, I could pick 7, I could pick my lucky number, but 100 grams ensures that if I have 100 grams of this compound, I therefore have 40.92 grams of carbon, so on and so forth for each of these elements. So I'm going to give you about 5 minutes to try to work this out. Our game plan is to get these quantities from grams into moles, divide by the smallest molar quantity to start making some ratios for those subscripts, and then taking those ratios and making subscripts out of them. So I'll give you 5 minutes to start working on this, so I would recommend that you pause the video and we'll go over the answer together. Okay, the first step here is I have the assumption that everything is out of 100 grams. So I take these numbers of grams that I have for each of the elements, and I'm going to convert each one of them into moles. So those arrows are just indicating that I divided by the molar mass of each one of these elements to find the number of moles of each of these. Then, out of these numbers, 3.406 moles of oxygen, that was the lowest number that I had here. So I took that and I made that the number that I divided by for each one of these quantities to determine what my ratio should be in my subscripts for the final compound here. So from those ratios, on my calculator, I got a 1.3 repeating for hydrogen, and then it came out to be about 1 for both carbon and oxygen. So that 1.33 is a problem here because we can't express that as a whole number subscript in my compound. So to get rid of that and to make it a whole number, I'm going to multiply that by a factor of 3, but I also have to multiply everything else by a factor of 3 as well. And that gives me a final ratio of 3 carbon atoms to 4 hydrogen atoms to 3 oxygen atoms. Or if I write that out as my empirical formula, C3H4O3.